Okay, we finished up the last video talking about the prefixes in the metric system. We have some ones that are used more commonly, some at the fringes that aren't used as much, and you've probably seen these before in some previous science class, and perhaps learned a mnemonic for remembering them, such as this one. King Henry died unexpectedly drinking chocolate milk. King Henry died unexpectedly drinking chocolate milk. K for kilo, H for hecto, D for deca. U is the unit, meter, liter, or gram for length, volume, and mass. And then we have deci, centi, milli, tenth, hundredth, and thousandth. So that's a commonly known one. A less commonly known mnemonic that I found online that I found humorous for those extreme prefixes at the very large and very small end of the spectrum that we don't use that often. For the really big ones, Karl Marx gave the proletariat 11 zeppelins, yo. And for the very small ones, Microsoft made no profit from anyone's Zunes, yo. And I find this one particularly funny because I used to own Microsoft Zune. If you don't know what that is, you'll just have to Google it, I guess. Okay, so we are going to be using the SI, or System International, or metric system in this class. And as I've said before, our primary units for length, mass, and time are going to be not the gram, but the kilogram. For length, it's the meter, and for time, it's the second. So those are going to be our primary units that we use for homework problems and things like that. Other systems include the CGS, which is basically a variation on the metric system that uses basically smaller units, grams instead of kilograms, centimeters instead of meters, seconds are still the same. And then the British engineering system, or the English or imperial systems of measurement, have feet for length, pounds, which is technically weight, not mass, and seconds. Seconds is still the same. So this is probably what we're all familiar with. You're used to measuring things in feet, pounds, and as an engineer, that's certainly what I'm used to. But we're going to be using kilograms, meters, and seconds. So oftentimes we'll have to convert between different units. You may be given one type of unit in a homework problem or a quiz question, and you need to convert it into something else. In the metric system, converting from one unit to another is pretty easy because it's all based around the power of 10. Converting into or from British or imperial units is a bit more work because it's certainly not based on powers of 10. It's based on, well, who knows what, but definitely not powers of 10. So when converting in between these two systems of measurement, we need to know what the conversion factors are. And these can be found, again, on the inside cover of your textbook, which I've also scanned and posted to Blackboard. Also, many calculators or your phone will convert units for you. So 1 meter is equal to 3.28084 feet. Okay, so that's an example of an equivalency that can be used to convert from one unit to another. Let's move on here to an example question. We want to know, what is the elevation in feet of Mount Everest, the tallest mountain on Earth, whose peak is 8,850 meters high? So I've got this already worked out in the slide. So first of all, the exact way that these two units relate to each other in terms of length is this right here. The inch, officially, what an inch is it's exactly equal to 2.54 centimeters. So if we wanted to convert feet to meters, or to know how many meters is equal to 1 foot, we would first take and convert that 1 foot to 12 inches. Then we would multiply it by this ratio, where we've got 1 inch on the bottom and 2.54 centimeters on the top. The inches will cancel each other out, and we'll be left with centimeters. Okay, so if we take 12 times 2.54, it gives us the 30.48 centimeters. But we don't want centimeters, we want meters. Okay, the centi in centimeters is times 10 to the negative 2. Okay, so to convert it from centimeters to meters, we need to move the decimal place twice. 1, 2. Okay, so 30.48 centimeters becomes 0.3048 meters. Okay, and again, here I'm showing that the inches cancel out and we're left with centimeters, and then we convert from centimeters to meters. Now, a quick word here on scientific notation. As I said, this right here is officially what a inch is equal to. It's exactly 2.54 centimeters. That's not a measured quantity. It is an exact, precise value. So we could almost think of this as 2.54000000 indefinitely. So it is not going to limit our significant figures. So this is not really 3 significant figures. This is essentially treat this as an unlimited number of significant figures. So if we look back up here to the example problem, we had 8,850. This is not really a significant value, so we want our answer to be 3 significant figures, basically. Okay, now having said that, look, I contradict myself. So 1 meter, if we want to convert that into feet, we would want to multiply by how many meters in how many feet. So the meters will cancel out, and what we'll be left with is feet. So we determined up here that 1 foot is equal to 0.3048 meters. So we would put meters on the bottom of this ratio. We're going to basically be dividing by 0.3048 and 1 to get this. Now, yeah, see here I have written in the PowerPoint 8,850 has 4 significant figures. It doesn't really. That really that 0 should not be considered as significant. But this was probably copied out of the textbook, and it really annoys me, but the textbook author has a tendency of doing this, of putting values into example problems or homework questions that have trailing zeros, and he wants them to be significant. He really should have put this into scientific notation if he wanted to make that significant. Or just make it something like 8,851. Then we would definitely know that that is a significant value because it's not a trailing zero. But I don't want to go on too much about that. It's just something that annoys me a bit. Okay, so here we have actually the answer to our question. We want 8,850 meters. We want to convert that into feet. So we take 8,850 multiplied by, this is our conversion factor, 3.281 feet for every 1 meter. Excuse me. Will equal 29,040 feet. Okay, that's reported to 4 significant figures. I think definitely a successful argument could be made that this should only be 3 significant figures. but let's focus here on the conversion factor rather than the sig figs. So you will likely see some homework problems that ask you, what is the conversion factor? So one thing I want to point out here is that a factor is something that you multiply by. So it's not what you would divide by, it's what you would multiply by. So if the question was, in this case, what is the conversion factor to convert meters to feet? The answer would be 3.281. That is what you are multiplying by in order to change the one unit, in this case meters, to the other of feet. So we're converting meters to feet by multiplying by 3.281. Okay, we're not dividing, we're multiplying. That's an important distinction. And there we go. See, there is the conversion factor. That's something to keep in mind for homework problems. Let's look at another example problem here. This time we're going to be converting derived units. So what we mean by a derived unit is it's not just as simple as converting feet, but we're converting square feet. We're measuring area of a floor plan. We've got a tiny house that's only 376 square feet. Now we want to know how many square meters is this. I see lots of mistakes when dividing or converting these derived units. So it's important to look at an example problem here. So you have to consider that a foot squared is literally a 1 foot by 1 foot square. Okay, 1 foot is equal to 12 inches. So that's equal to 12 inches. So we're talking about a square that is 12, I know I'm not exactly drawing 12 squares, but you get the idea. 12 by 12. So if we have 12 rows and 12 columns, and we multiply that to find the area, that is 144 square inches. The common mistake I see is that people forget all about the fact that we are squaring these units. And they just think, oh, how many square inches are there in a square foot? There are 12. No, there's not 12, there's 144. What you need to do is you need to square the conversion factor here, and that means squaring both the top and bottom number. So 12 squared is 144, 1 squared is still just 1. So in order to convert 1 square foot, we multiply it by, we put the unit that we're wanting to convert on the bottom, so square feet and square feet on the bottom. Those square feet will cancel out with those square feet, and that will leave us with square inches on the top. So it's 144. That is the conversion. Okay, so don't forget to square these numbers when dealing with derived units. Okay, so if we want to convert a square foot into a square meter, what we're doing here is we're I realize this is kind of confusing the way I have this set up, but we're 1 inch is equal to 0.0254 meters. That's 2.54 centimeters. And if we square the top, we also square the bottom. And I've realized there's a mistake here in the PowerPoint. That's why I was kind of being a little confused looking at this. This is 144. Okay, the answer comes out right. I just didn't change this right here. So 1 square foot is 144 square inches multiplied by 0.0254 meters squared over 1 squared. So if we work that out on our calculator and take 144 multiplied by 0.0254 squared, we get this answer right here, 0.0929 square meters. That is the conversion factor between square feet and square meters. So if we take our 376 square feet and multiply it by our conversion factor, we get an answer here of 34.9 square meters. And it looks like I'm coming up pretty close on my 15-minute limit again. So this is a good place to stop, and we'll resume in the next video.